the required ampacity for the new circuit is 26.5 amps. Now let's discuss derating for conduit size and the number of conductors. According to table 310.15 b3 of the National Electrical Code, the derating factor for 10 current carrying conductors in a conduit is 50%. Therefore, the derated ampacity for the new circuit is 26.5 amps times 50%, which equals 13.25 amps. The maximum breaker size that can be used is 50 amps, which is larger than the required ampacity. Therefore, the breaker can be used as is. Use number 10 THHN conductors to feed the new circuit. Since the breaker is larger than the required ampacity, there is no need to oversize the conductors. In conclusion, you can install the new circuit in the existing conduit with the other loads. The breaker size of 50 amps is acceptable, even though it is larger than the required ampacity, because the conductors are derated for the conduit size and number of conductors. Now, let's delve deeper into the concepts to ensure a comprehensive understanding. Firstly, understanding ampacity is crucial. Ampacity is the current in amps that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. It's essentially the safe current carrying capacity of a wire. Secondly, derating conductors is a necessary safety measure. When multiple current carrying conductors are bundled together in a conduit, the heat generated by each conductor can raise the overall temperature within the conduit. This increased temperature reduces the ampacity of each conductor. The NEC provides tables, like 310.15 b3 8 to determine the appropriate derating factor based on the number of current carrying conductors in the conduit. These tables specify the percentage reduction in ampacity that must be applied. The term current carrying conductors is important. Grounding conductors and neutral conductors that only carry the unbalanced load in a three-phase system are typically not counted as current carrying conductors for derating purposes. However, if a neutral conductor carries a significant amount of harmonic current, it may need to be counted. Refer to NEC guidelines for specific rules on neutral conductor derating. The calculation of derated ampacity is straightforward. You multiply the initial ampacity of the conductor, as determined by its size and insulation type, by the derating factor. In this case, a number 10 THHN conductor has a certain ampacity rating, but with 10 current carrying conductors in the conduit, that ampacity is reduced by 50%. This derated ampacity is the maximum current the conductor can safely carry in that specific installation. Breaker sizing is another critical aspect of circuit protection. A breaker is designed to protect the conductor from overcurrent situations, such as short circuits and overloads. The breaker should be sized to protect the conductor, not necessarily to match the load exactly. The NEC specifies rules for breaker sizing based on the ampacity of the conductor. Generally, the breaker should not be larger than the conductor's ampacity. However, there are exceptions, particularly when dealing with motor circuits, where the breaker may need to be sized larger to accommodate the motor's inrush current during startup. In the given scenario, the maximum breaker size is 50 amps, which is larger than the required ampacity of 26.5 amps for the new load. However, because the conductors are being derated due to the number of conductors in a conduit, the 50 amp breaker can still be used. This is because the derated ampacity of the number 10 THHN conductor is less than the breaker rating, ensuring that the breaker will trip before the conductor is overloaded. It's important to note that the NEC allows for the next standard overcurrent device rating in certain situations, but it's crucial to verify that this is permissible based on this specific application and the conductor's ampacity after derating. The choice of number 10 THHN conductors is based on the initial ampacity requirement of 26.5 amps and the need to account for derating. THHN insulation is a common choice for conduit installations due to its heat resistance and moisture resistance. Other insulation types, such as THWN, may also be suitable depending on the specific environmental conditions. The NEC provides tables that list the ampacity of conductors based on their size and insulation type. These tables are essential for selecting the appropriate conductor size for a given application. When installing the new circuit in the existing conduit, it's important to ensure that the conduit is not overcrowded. Overcrowded conduits can make it difficult to pull wires and can also contribute to heat buildup. The NEC specifies fill limits for conduits, which are based on the conduit size and the number and size of conductors. These fill limits must be adhered to in order to ensure a safe and reliable installation. In summary, adding a new 208 volts AC circuit to an existing conduit requires careful consideration of ampacity, derating, breaker sizing, and conduit fill. The NEC provides detailed guidelines for each of these aspects, and it's essential to follow these guidelines to ensure a safe and compliant installation. The key steps include, firstly, calculating the required ampacity of the new circuit. Secondly, determining the derating factor based on the number of current carrying conductors in the conduit using NEC table 310.15. B3. Thirdly, calculating the derated ampacity of the conductors. Fourthly, selecting the appropriate conductor size and insulation type based on the required ampacity and derating. Fifthly, selecting a breaker size that is appropriate for the conductor ampacity and the load requirements, while adhering to NEC guidelines. And sixthly, ensuring that the conduit fill limits are not exceeded. Understanding the NEC is paramount for safe electrical installations. Now let's consider the practical implications of these calculations. Let's assume that the number 10 THHN wire, prior to derating, is rated for 30 amps. With a 50% derating factor, the allowable ampacity is reduced to 15 amps. This is calculated by taking 30 amps and multiplying it by 0.5, or 50%, which results in 15 amps. Although the load only requires 26.5 amps, the derating factor forces the effective capacity of the wiring down to 15 amps, significantly less than what the load requires. However, the 50 amp breaker is still permitted in this case. Let's explore why. The reason that the 50 amp breaker can be used, despite the severe derating, comes down to the specific rules within the NEC. Because this AC unit has a marked maximum overcurrent protection device, it is permitted to use the 50 amp breaker, even if that breaker exceeds the ampacity of the wire. This is a common situation, but it is important to remember that the presence of the existing overload protection device rating is required to make this code compliant. The key takeaway is that the equipment listing and manufacturer's instructions play a vital role in determining the correct electrical installation. Now consider what would happen if the maximum overcurrent protection device was not specified, or was significantly lower. In those cases, the rules for standard circuit supply, and the breaker cannot be size greater than the ampacity of the conductors. NEC table 310.16 provides the ampacity of insulated conductors rated up to 600 volts, 60 degrees Celsius to 90 degrees Celsius. A number 10 copper conductor with THHN insulation rated at 90 degrees Celsius has an ampacity of 40 amps. Now consider that number 12 copper conductors were used. The ampacity of a number 12 copper conductor with THHN insulation rated at 90 degrees Celsius is 30 amps before derating. After a 50% derating, the allowable ampacity is reduced to 15 amps. A 15 amp capacity may not be sufficient for a new load, especially if there are existing loads on the circuit. If we were to install a new load of 14 amps, this would exceed the allowable ampacity by close to its maximum capacity. The amount of the new load plus the existing loads cannot exceed the derated ampacity of the conductors. Let's look at another example. Suppose you have 6 number 12 American wire gauge conductors and 4 number 10 American wire gauge conductors. The conductors are all THHN copper in the same conduit. What is the allowable ampacity after derating? Firstly, count all the current carrying conductors. There are 10 total. Secondly, find the appropriate derating factor in NEC table 310.15. B3. 10 conductors require a 50% derating. Thirdly, find the allowable ampacity of number 12 and number 10 American wire gauge THHN conductors. Number 12 American wire gauge THHN is rated for 30 amps. Number 10 American wire gauge THHN is rated for 40 amps. Fourthly, apply the derating factor. The number 12 American wire gauge conductors are derated to 15 amps, and the number 10 American wire gauge conductors are derated to 20 amps. A common mistake is to add the conductor ampacities together before derating. The ampacity of each conductor must be determined individually. Always consult the most recent edition of the NEC and local amendments for the most accurate and up-to-date information.